This is kinematic question. The diagram shows the speed time graph of a car. It travels at 28 meters per second for 20 seconds and then decelerate until it stops after further 10 seconds. So we have to calculate the deceleration. So here in this, from here to here, the car is moving at a speed of 28 meters per second, and this is the constant speed. But up from here, it starts decelerating. The speed is decreasing now. Okay, and now we have to find the deceleration, and deceleration is negative acceleration, but this is speed time graph. In speed time graph, the gradient is called acceleration. So but here in this line, acceleration is negative, so we have to find the gradient of this line. So what is the gradient of this line? Let me use rise over run. So this is our rise, sorry. This is rise, and the rise is 28, and this is run. The run is 20 to 30, which is 10. Therefore, the gradient, which is deceleration, that is gradient, which is rise over run. And the rise is it is 28, and the run is 10. As the line is coming down, if you look at the line from left to right, this line is coming down, so the gradient will be negative. So it is minus 2.8. So acceleration, so it is not acceleration, is minus 2.8 meter per second square. But when we use the word deceleration, we ignore the negative sign, because it is understood the word deceleration is the meaning of deceleration is negative acceleration. So we will use in this case plus 2.8 meter per second square. So the answer is 2.8 meter per second square. In the next part, we have to calculate the distance traveled during the 30 seconds. So the 30 seconds, this is the time of the whole of the journey. So distance is basically the area under the graph. So, okay, the area, to find the area of this graph, there are two approaches. First, find the area of this rectangle and then this triangle, and then I add those two areas. This will give us the total area, and which will be the distance traveled. And the second method is to find the area of this trapezium. So the area of trapezium is, that is 1/2 height into sum of the parallel sides. This is the area of trapezium. So here 1/2, the height is this is parallel side and this is parallel side, and the height is 28. Sum of parallel side. The first side is, this side is 30. The length of this side is 30, and here this length is 20. Sorry, this 20 is from here to here. So 20. So it is 2 ones and 14 times 50. The total is 700. So it is 700. So the total area is 700, and this area is basically the distance traveled. So the distance traveled is 700, and the unit of distance is meter. So we will use meter, 700 meter. Suppose there is a third part, the finding the average speed of the whole journey. Average speed of whole journey. Student, the average speed of the whole journey is total distance traveled, total distance over total time. And total distance traveled is 700 meter and the total time is 30 seconds. Okay. So let me simplify this one. 700 over 30, which is 23.33. 23.3 meter per second. So average speed of the whole journey is total distance over total time, and the total distance was 700 meter and the total time was 30 seconds. So it is meter per second, 23.3 meter per second.